This video is on composition of functions. The skill work is very similar to what you did in algebra of functions. The concept is new in that we are making a new function. We're taking one function, the output of one function, and using it as the input for another function instead of just some random expression like you've been doing before. So this should go pretty well, hopefully, although some of the math is tricky. So the notation for this is y equals f of g of x. So you could also write it like this, f of g of x. So this right here, we usually would say f compose g of x, and this one here, f of g of x. That represents the composite function created by plugging outputs of g into f. The inputs of f of g, sometimes it looks like fog, are the x's that we initially plug into g. The outputs of f of g are the final outputs we get from f. So the domain is tricky here, so we have to make sure that we start in the middle here with the inside function, that all possible inputs for g, which will give us a value in the range, so we don't want an undefined situation. So notice that this means a number can't possibly be in the domain of f of g unless it is in the domain of g, or whatever the inner function is. Even when we have to be careful, even then we have to be careful, because g might output something that we are not allowed to plug into f. Okay, so we also have to take a look at the new function. We have to check that domain, but we also have to check that inner function. We don't really need to worry about the outer function. That kind of takes care of itself. So as long as you have something in there in the G, that works. Okay, before we go on any further, I want you to take a look at page 58 in your book and read. Make sure you read, if you haven't already, about the domain of a composite function. And so we have these two functions here, and we have to worry about the inner function, because if we start with an undefined situation, like if x is 2/3, then we would end up getting 0 in a denominator. So we can't have that. So we have to have that restriction. So we would have x not equal to 2/3 for sure. Then we also don't want to end up with an f that is undefined, a value that when we plug it into f is undefined. So we take the g of x and we set it equal to the restriction on f of x. Does that make sense? So we can't have x equal to 1, so x not equal to to 1, so we plug that in here. So g of x can't equal 1, so it's not that we're finding the domain restriction for f itself. We're actually finding when g would be f's domain restriction. So that's a little bit different. So if you solve that out, you can follow down, just clear the denominator or cross multiply, and you would get x equals 2. So we cannot have x equals 2 either. So we don't even know what the composition is. Then you would usually pick that up on your final answer for your composition too, if you check that restriction. But if you just know right off the bat to do this piece here, set g of x equal to 1, that should really help. So now let's go back to the other page. Okay, so here we are at the notes page, and we're looking at the examples. And what I just went over was be careful, because G might output something that we're not allowed to plug into F, so we need to watch for that. So here we are with f of x equals 3x plus 1 and g of x equals x squared plus 5. So g compose f of 4. We could actually write it in this format. Might be a little bit easier to work with. G of f of 4. It's usually easier to think of. Remember, this is not meaning multiply. It will never work that way. It won't come out to be the same answer. I shouldn't say never. There could be a fluke thing, maybe. So I'm going to figure out what f of 4 is. So I'm going to follow that through. So f of 4. Here's my f function. So it's going to be g of 3 times 4 plus 1. Okay. So I put that f of 4 in a different color. I put it in purple so we can distinguish that. So then we have 3 times 4 plus 1 would be 13. So now we're working with g of 13. And now we're going to plug that 13 in for x in the g function here. So 13 squared plus 5. And that will give us 174. So that's like having the point 4 is what we started with right here. Okay. And 174 was our final input. Okay, output. Sorry, output. So input, this is our original input, and our final output. So start thinking of it as that way. You don't need to worry too much about what's in between. Okay, and neither f or g functions have any restrictions on them, so we're in good shape there. Unless we're having a restriction to begin with, we should be good on those. Okay, so if you want to pause the video and try these two right here, f compose f of -1 and g compose g of 2, and just write it out just like I did and see how that goes. Or if you kind of want to figure them out a little separately and clump them together on separate lines, you can do that too. But go for it and then come back and check. Okay, so here are the answers for this. We start with -1. We pop it into the f function. Remember, doing f of f, we end up with -2. So now that just becomes f of -2. We go back over to the f and plug that in. We get 3 times -2 plus 1 is -5. So output is going to be -5 when we started with x equals 1. Same here for g of 2. I plugged in to the g function this time the 2, so I get 9, and then again plug that into the outer function, which was also g, and I get 86 for my output. So that turns out to a lot of steps all the time. So what we can do is, rather than having working our way through both functions for every input, we'll build a formula that summarizes what happens. And that's what we do when we do f of g of x and we plug in and use it as a formula. We get that output and then we can just directly pop in. So that works out really nicely, and that's where it's kind of similar to algebra functions that you're working with, the algebra on that part. So let's go ahead and do a couple of these. I'll use this color. So we are going to take those same functions and find the formula f of g of x. So what we're doing is keeping our outer function on the outside there, and then I'm going to put in the middle here, I'm going to put the g function. So g of x was x squared plus 5. And now I'm going to set that equal to 3x plus 1. Okay, so this is what it looks like. This was f of g of x, and now I'm going to take that g of x, just like I did with algebra functions, and pop it in for x. Except this is a little different because I'm actually starting with a function inside there, not just some random thing. So I'm going to come out with a new function. And I have to check the domain restrictions, which on this one I don't have any. And then we'll talk about range as well here. So since you've done this skill before of putting x squared plus 5 or something similar in for your input everywhere you see that, then go ahead and pause the video and try that. And then I will work through it. It's pretty quick, but I want you to just pause and try it. Okay, so I can write this as f of g of x equals 3 times x squared plus 5 plus 1. And then now I'm going to just distribute the 3 there. The square is inside the parentheses there to only attach to the x, so I don't want to expand that or anything. Sometimes I've seen that happen. And then I have 3x squared plus 15 plus 1. And that all boils down to being 3x squared plus 16. So my final answer is f of g of x equals 3x squared plus 16. Usually you can just kind of drag it down there. That's what I do. All right, so that's doing the algebra part. Now, if we have tables, it does get a little tricky. You've done some things with functions already, but now we're doing the composition. It can be tricky. So let's see how that goes. Actually, before we move on, I wanted to talk about domain and range. So we have the domain on this would be all real numbers. And then the range, we have to think of like what's the highest output that we'd have would be 16, because no matter what we put in for x, if it's 0, it'd be 16. If it's -1, it would be higher than that, right? Because this square always makes this first term positive. So we would have y is greater than or equal to 16, or a lot of times just write it as 16 to infinity like that. And you could write the range, the domain as -infinity to positive infinity as well if you want to use interval notation. So I've kind of written both there. So actually this is a great place to stop for this video because the rest of this page is going to be tables, the next couple pages. So we'll do the tables in a separate video for part 2. This will probably be a bunch of parts. Sorry about that, but I want to keep them short. So see you soon.